Plane meter. Yes. Student, I'll discuss only advanced numerical based on plane meter for 12th class, or I can say J advanced, not for CBSE. Okay. So this will go through there. What's the question? Have a look once. Okay. Yes, beta. Have a look of the questions here. So, what's the question, my dear? Listen to me very, very carefully. Okay. Student, question is that I can say, my dear. Yes. Hmm. But this is the source here. Yes, beta. This is you can take as a source. Right. Source is here only. Right, my dear. Okay. Source length you can take. This is what L. What is meant? Source length you can take. This is what remains L. Okay. Fine. Students, for this condition, my dear, this is the mirror. Hmm, this is the mirror. This is the mirror. Right. Okay. So there is some common things with that which you can take into consideration. This is L beta. This length is L. Beta already mentioned here. The length of the mirror is L only, right? So you can take a student. This length is remains L only. Fine. What we wish to find here? Determine the length of reflected part of the light on the screen. This is the screen. This is the screen, right? Or you can see button is sphere. Find field of view. What, my dear? Find field of view. Right. Okay. So if you student wish to find field of view, I guess there is some common procedure. What, my dear? You can say for this condition. Okay. Which I can say the reflected part this side. Reflected parts from this side only. Right. Okay. So Vita, what's field of view? I hope all of you remember. Otherwise, drawing. Vita first ray was end of the mirror. Let us suppose I'm falling over here. So this ray you can say Vita definitely will move like this. And this is what, my dear? It's a screen. It's a screen. Vita, just do what normal for here, my dear. So you can see if this is theta. So this is also theta. This is also theta. You can see, my dear. This is the theta. So you can say this is also theta. Listen carefully. Now, beta, another is from source. So another is from source, beta, falls. Another end of the mirror. So finally, you can say a ray falls over here. A ray falls over here. Okay, fine. That's a party for these conditions. The written show what is the things. Yes. Okay. I'll apply beta basic geometry here. Friend, I'll apply basic geometry here. Let us suppose this point I'm considering O. This what I'm considering O, right? Okay. So just here, extend which are this part. Jai Sri I'm a student. Okay. Now this is L beta, right? This is L beta. You know this is also L. You can take it. It's nothing but it's a length of It's the length of mirror. Okay. Now, bacha, this is that. Listen better carefully, yaar. Beta, be focused in the class, bacha. You can talk it up personally, bacha, not in the live session, bacha. I'll not reply anything, bacha. Avi, what's your name? Can you write your name, bacha? Can you write your name and from where are you watching? Which batch from you? Yes, bacha. Okay. So this is O beta I have taken here. Let the already beta mentioned in this. I can say in the beta question. This is source S. So this is remain source beta. Let us suppose beta I'm just considering this is A, B, C. This is D beta. This is E and F. Right. Okay. So this is a diagram here. Just beta go through this. Re-diagram. Bacha, here I can see one thing here from geometry. From this diagram, I can say this is what AC. AC is nothing beta. What you can say? AB plus AC. AB plus BC. AC beta, what you can write? This is AC. So what? AB plus BC. Beta, we wish to find here what is AB because this is our target. This is the field of view. My dear, this is the field of view. So we can say this is what AB. So what AB bacha party? This is AC minus BC. What, my dear? This is AC minus BC. Okay, fine. Now, Vajapati. Here you are, this I'm going to apply some concept of similarity, similar triangle. Bachas ye, this is theta here. So, beta, let us suppose I'm calling here. If this angle is theta, this angle, just keep in mind. If this theta, bacha, so you can see here for this concept, this is also theta. This is also theta. This is theta, bacha, so I can say this angle is also theta. Still, I can say this angle is also theta. If this angle is theta beta, so what I can say, students, what I can say, my dear, for these conditions, this is what triangle SDO beta for triangle SDO, similar to what which I got it? Triangle OCA. Yes, listen to it carefully. Triangle O, or you can say SDO is equals to bacha, this triangle here. O, C, and A. Beta, these all are what you can say bacha. Triangle O, C, A is what? Similar. O, C, A is what, my dear? You can say similar. If this is similar here, so I hope all of you remember property of similar triangle. Property of similar triangle. Beta, what you can say? SD upon OC. Beta, perpendicular by perpendicular. Perpendicular by perpendicular. So what you can say? This is SD upon bacha OC, which is equals to what? But I can say here, base upon base. Simple. So this is what you can say DO. DO upon beta what you can say AC. SD is known for us. That is L. OC beta OC. Yes. This is what 12. This is what 12 bacha ji. Right beta. SJ is what, my dear? SJ, my dear. That is what L. OC beta what you can say? This is what 12. Which is equals to beta. OD. This is it. Beta remains here. What you can say? OD is equals to L beta only. Mentioned here in the question itself. So this is L. But I will get here AC from here. Will get might get AC from here. Yeah. You can this is what air cancel there. So finally you can write AC, which is equals to 2L. Okay. So beta, we got here. I can say this length. But we are interested to find AB, not AC, right, my dear? So AC, what you will get? That is what? 2L. So we can write Vajapati here because we used to find AB in air. So this is what you can see 2L. At anyhow, we have to find VC. At anyhow, my dear, what we have to find? VC. Okay. So yeah, if we wish to find VC Vajapati, then what you can do? Yes, again, yeah, think concept of similar triangle. Concept of a similar triangle. But listen carefully here. You can say this triangle. This is what? C, B, and E. C, B, and E. Right, bacha body. Okay, then bacha what you can say? This is what, yeah. Next triangle, bacha. That is S, and beta what you can say? F, and what? E. This entire triangle, bacha. S, F, and E. Beta what you can say, my dear? This is S, F, and E. Listen beta carefully here. Beta, this is E, C, and B. Beta, this is E, C, and V. Next property, what you can say? S, F, and E. These two are similar. What, my dear? These two are similar, beta G. So again, here, I'll apply beta property of similar triangle. So what, my dear? Triangle. This is S, F, E. My dear, triangle S, F, E. Similar to what? Triangle E, C, B. Beta, similar to what? Triangle beta E, C, and B. Right. Okay, bacha. Now beta what? Again, here apply property. Perpendicular by perpendicular is equals to base upon base, my dear. Okay, SF here. So this must be what? 12 only. So perpendicular is 12, bacha. And this is what? L. So right, bacha, party. This is SF upon beta the EC is equals to beta base here. So this is what? FE. What, my dear? FE. I'll write here once. My dear, this is FE. Upon beta, what's here? This is BC. This is what, my dear? You can say BC, right, beta? So SF beta, according to geometry, you can write beta. This is what? SF is equals to 12. So you can write beta. This is 12 here. And beta, what about EC here? EC is what? EC beta, have a look diagram. This is L. This is L, my dear. This is L, beta, buddy. Is equals to what, beta? FE. FE beta. What is the F here? This is remains L. Because this is L, so this is remains L, my dear. So we can say L here. BCB is to find. BCB is to find. So again, you can say beta, buddy, what? This L, this L finish. So BC, what you can write, beta, buddy? L by 2. BC beta, what you can say, this is L by 2. If BC be found here, so this beta feed up value over there. So minus L by 2 beta, 2 to the 4. So what answer you can write beta finally? 3L by 2. Yes. There is option beta. There is option, students. I can see, I can write the options like America, Bombay, Canada, and last beta I can say Delhi. So what option is correct, my dear? That is, you can say beta, Canada is correct answer. What, my dear? You can say Canada is the correct answer. Okay, I hope you got it with this entire solution of the questions, my dear. Okay, fine. Now, beta, have a look at next question here. Students, have a look at next question here. Okay, I guess there is one more easy question. In advanced lesson there, so I don't want to discuss easy questions over here. Right, I can say plain mirror. So after this, bacha, I wanted to discuss here. That is literally very good questions. Yes, beta, that is very good question here, and totally designed only for beta. I can say advanced here. Literally, beta. This question are literally only designed for advanced questions. Right. So just give me some time. Yes, beta. So which question you need to do here? Hmm. Yes, beta. Just do everyone here this question. In fact, I remember the questions, but I wanted to just give you, I can say, correct information on the questions. Right. Hmm. Basically, beta, in this questionnaire, what's the mention? Beta J, there is square frame. Yes, beta. For identical, what's the question, my dear? Listen carefully here. Beta, there is what? Four identical plane mirror. What, my dear? There are four identical plane mirror, right? Are made to stand vertically to form a square, right? So which just leave here. I can say pay attention. And I can say solution of the question. Because there are four plane mirror here, and this four plane mirror I can say identical. So just you will connect this four plane mirror. So you can get formation of a square. You can get my idea. This is what formation of a square. Yes. So you can take for consideration side of a square, which is equals to a. You can take my dear as a consideration. That is what side of a square is nothing but it's a side of a square. What was that? You can take a. Okay. So what's the mention? This thing I mentioned in the questions. Let us suppose this point is M. This point is what, my dear? M only. Okay. Anywhere here you can watch this solution anytime, right? It's literally beta. Very good question, my dear. Very good questions, my dear. So beta, this is point M. Beta, this is point A, B, C, and D. What, my dear? A, B, C, and D. So I think there are four identical plane mirrors and formation of I can say a square. This is the questions. Now I can say beta for this question, object started motion from here only. Students, beta, God bless you. Object started motion from here only beta. You can see this is we wish to find this value of theta. Question is very simple here, but solution little like it's tough here. So find theta. If there is a condition, find theta if this incident ray finally, if this incident ray finally, you can say incident ray what only beta. You can say this is what after two reflection reaches corner D. Find theta if incident ray after two reflection reaches corner D. This is the questions, my dear. Right. Okay. So student, I'll draw a first normal from here only. Listen carefully, my dear. It's literally a very good questions. Yes, beta. So this is a theta. So we can easily say this is 90. This is my dear 90 minus theta. This is my dear 90 minus theta. So student, if this is 90 minus theta, so you can easily say, sir, this is definitely theta. This is what? Definitely theta. This is what? Definitely theta. If this is 90 minus theta, this is theta, this is theta. You can easily say, sir, this angle is also, what, my dear? 90 minus theta. Huh. Listen here, I can see carefully. Hmm. Yes, beta. So this is beta what? 90 minus theta. This is theta, this is what? Beta remains theta, yeah. So this is what beta 90 minus theta. This is 90 minus theta, Vacha. So what you can write? This is what? Beta g remains theta. This is what you can say remains theta. If this is theta, Vacha. So you can easily say this angle is what? It remains 90 degree. This angle is what? You can say remains 90 degree. Right, my dear? Okay. If this is theta, yeah. So what you can say? This angle is 90 minus theta. This is what you can say beta 90 minus theta. This angle you can say this is what theta. This is what theta. Beta you can say this angle. This way you can say this angle is what remains theta. But I'm not taking theta. I'm taking what angle of deviation delta. Why? Ray is what deviated. Ray is what deviated from here. Which so here is this data beta. I'm considering here this is what angle of deviation, which is equals to delta, which is equals to delta. It's a good question here. Just we pay attention to learn the entire concept. Okay. Now, because this is the midpoint here, so you can easily say this is what beta is a by 2. This is what beta is a by 2. This is a by 2 beta. This I can say it a reflected point here or hitting point of the incident ray. I'm just calling. Let us suppose this is my dear B. This is what Q. Yes, beta. It's literally very good question, bacha. Literally, beta, very good question. Yeah, rarely will get solution, which I'm solving over here. Rarely will get solution on YouTube or anywhere. Open challenge. Open challenge. You will go anywhere. You will not get it. 100% there. Which I'm solving here, you will not get it. 100%. So now, bacha, have a look here. Bacha, see, have a look. I can see triangle. Triangle, beta, M, P, and M, A, and P. Beta, have a look at triangle, my dear. M, A, and P, bacha. So this is students triangle. This is what MAP. Bacha, I'll find here. We wish to find tan theta from beta this triangle here. So I hope all of you remember. Tan theta nothing but it's what beta is? Perpendicular by base. Perpendicular by base, right beta? Okay. So what's perpendicular? This is what you can see PA. So you can write which party further here. Tan theta. It's what you can say AP upon beta ampere. Upon beta, what you can say MP. And MP nothing here. It's A by 2. Simply, beta, you can write here. Easily, you can write, my dear. What beta? You can write AP is equals to MP tan theta. AP beta, what will be? This is what? MP tan theta. Okay, fine. Now, beta, APR we know. You can write beta from diagram. AP is what? MP, not AP. So AP you can write beta finally. AP is equals to this is A by 2 times of tan theta. AP beta, what you can say, this is A by 2 of tan theta, right, my dear? Okay, fine. So now, bacha, again here, I'll make, I wanted more things. Bacha, here, beta, now I wanted to find here. This is what, again, beta, I'll take triangle. Students, I'll take triangle here. That is what you can say P, B, and Q. What, my dear? I'll take triangle, beta. This is P, B, and beta. This is what? Q. Beta, this is P, B, and Q, bacha party. So here, beta, again I'll write for for students for triangle beta. This is P, B, and Q. P, B, and Q. Right, beta, for triangle here. Okay. So beta, again I'll find beta. We used to find tan means tan theta bacha. So again you can write tan theta is what beta? Perpendicular. So this is what you can say BP upon BQ. From triangle layer you can see here. Simple. What is tan theta? This is perpendicular upon base here. Base is what you can see BQ beta. Perpendicular to what we can say this is BP. So finally you can write here BP. Bacha party. BQ here, what we can see BQ? BQ we can find here from normal geometry. So bacha party you can say here BP, right? So beta just do one thing. We can find BQ here. How? Beta for getting BQ, beta if you want to find BQ here, then again apply geometry. Beta is it for this question. I'm going to there just step beta. This is my dear step one for this question, right? Which I have shown till now. Now beta I'll do your step two here only. Yes. Yes, beta. So this is my dear step two of the questions. What was it, Bati? Here, yeah, I'll apply beta. I wanted to apply geometry. This is what BC. BC beta I can write here. It's nothing but it's basically BQ plus QC. BQ plus QC. Here we wish to find what is BQ. So you can say bacha party. BQ are easily you can say this is BC minus QC. BC minus QC. That is what? BQ Vacha party. Okay, fine. So Vacha party here you can see here for this condition. BP minus BC here. So again here just beta find this tan beta deviation. Student you have to find from here. That is what I can say tan deviation. Right. So beta ji for tan deviation here. How can we get Vacha party? How can we get Vacha party? Okay. Beta, do one thing. BP beta we all got. Yes, beta we can also yeah, use. Beta this BC relation. Find my dear. Then yeah, beta for further we wish to find what QC. So beta for QCR, again we can apply bacha. In step 3, student, you can apply step 3 here, tan theta formula. So you can write over here, tan del is what bacha? This is both are it's equal bacha party. So tan del beta, what you can write? This is what perpendicular bacha. You can see the diagram here. This is beta CD perpendicular and this is base beta QCR. So you can see this is what basically CD by QC. So you can write with at the same time here. Tan delta is nothing, it's a tan theta. So you can say bacha, this is what tan theta is equals to bacha, both are same here. Yes, beta. This is what you can say CD. This is what A upon QC. At anyhow we have to find QC. At anyhow we have to find QC. Okay. So beta for QC what we can say here? BC minus BQ. BC minus BQ. Okay. So beta from this equation here, let us suppose equation number 1 I'm calling. So here I can write here. In what beta I can say this is step 4. Yes beta. This is step 4 beta G. Right. So beta what I can say? First I'll write here. BC is equals to beta. This is BQ plus QC. So QC beta what we can say? BC minus BQ. BC minus BQ. And BC beta AR, this is what? A minus beta is BQ. Minus beta is BQ. So we have to find it. What? If you want to find QC, so we have to must find BQ. You have to must find beta BQ. How can we get BQ? Yes, the idea. We have idea with that. Just see carefully at these questions. But I can write here AB, this beta side. You can see carefully. AB you can write AP plus BP. AB you can write AB, you can write AP plus BP. So beta, this is step 5 here. It's lengthy question here. So I'm taking a step by step so that you can easily understand. But yeah, what you can say, this is what AB is equals to what, my dear? This is AP plus BP. We wish to find here, I can say that is which AP we already found. So we wish to find BP here. So BP, what you can say? This is AB minus AP. AB are it's nothing but it's side of the square. AB with nothing at it. So what you can side of the square here. So this is what we need here. This is what remains A. This is remains A, right, beta? God bless you, beta. God bless you. This is A. Beta minus APR, what? A already we found here. A by 2 tan theta. Yeah, be patient, student. This question, yeah, literally, let me look here. Be patient here. So you can write this is BP. BP is what you can say? A minus A by 2 tan theta. Okay. So BPR we can use again, beta. I'll make here. I'll use this triangle. What triangle? B, P, and Q. Yes, beta. Again, I'll use the once here. In this step, I can say 6. So, beta, tan theta. It's nothing but BP upon beta, I can say BQ. Yes, we'll get here. BQ from here only. So, let's say I can write here. This is the tan theta. BP beta already be found. This is BP. So, you can write beta A minus A by 2 tan theta. A minus A by 2 tan theta. Upon which party, this is what? BQ. So finally, you got value of BQ, my dear. What is BQ here? This is A minus A by 2 tan theta. Upon which this is tan theta. Now you got beta. What value of BQ? This BQ, bacha, you can feed over there. Then you will get QC. Then you will get QC. Okay. So bacha party. Yes, I wanted to turn the page, student. Just take snapshot. Yes. Yes, beta. Now here I'm going to continue with the party. I can say this part here. So this is step 6 beta. Now here, this is you can say step 7. So finally again I wanted to use here this formula and this triangle. You can see C, D, and Q beta. So here I can write this is tan theta here. Tan delta is what beta? You can say CD by QC. QC are we already found. QC beta value from here. We can write easily. So what's the party? You can say here for this condition. This is what tan theta beta. CD is A upon QC. CD is what? A upon QC. QC beta, we can write here from here. What BC is equal to what? You can say BQ plus QC. QC is what? You can say BC minus BQ. I'll beta write here only once. QC beta. This is what you can say BC minus BQ. BQ beta, this just now we found here. Just now we found Bachar party. BQ here. And BC is what? A. So we can say Bachar party. This is my dear QC is equals to A minus beta. What's the BQ? This is A minus A by 2 tan theta. Upon beta, what we can say? Tan theta. Right now. This is the QC we got finally. Right. This value beta we can fit in this value, tan theta. So you can write here tan theta. This is A upon QC. So just beta, keep patience here for long solution of the question, my dear. Tan theta here, what? This is remains A bacha party. QC here, you can say this is A minus A by 2 tan theta. Beta here only, not for entire. This is what? Tan theta. Yes, beta. This is what? Tan theta. Yes, beta जी. हाँ, beta जी, further this one. So bacha, yes, beta, you can write. Beta, just calculate further here. So it's a normal part. I can see we already finished. Just calculation simply we have. It's a lengthy calculation. So this is what, my dear? Tan theta. So you can write, bacha, this is A times of tan theta. Upon bacha party, you can say this is what. Just do here. I can say this here. A tan theta minus A plus beta g. A by 2 tan theta. A by 2 what, my dear? Tan theta. Right. Okay. So but I'll continue on next step here. But student takes snapshot. Student takes snapshot, my dear. I'll continue on the next page. Okay, fine. I hope you have taken. So बच्चा जी, tan theta. A of tan theta बच्चा. This is your A plus A by 2. You can say 3 by 2 times of A tan theta minus बच्चा जी AR. So finally beta, you can just say this tan and this tan cancel. This tan cancel बच्चा. Right. Okay. So finally बच्चा, just solve here further. Beta, just calculate. So you can say this A finished everywhere. So 3 by 2 tan theta minus 1 equals 1. You can say like that. So this is 3 by 2 bacha, tan theta is equals to 2. So 3 tan theta is equals to 4. So tan theta is what? We can say 4 by 3. Tan theta what? You can say 4 by 3. But you know, beta, by the way, what's the option? I wanted to write your options once so that you can answer the questions. This is beta g tan inverse 0.75. Beta Bombay. This is cot inverse 0.75 here. Canada beta. This is sine inverse 0.75. Delhi बच्चा से. This is cos inverse 0.75. Right. So your answer tan cos, no, not at all. So you can see easily 4 by 3, not 4 by, I can see 7 by 5, bachcha, 0.75. So this is not possible. This is not possible. This is not possible. You have only one answer here. So you can write now, bachcha, this is what? cot theta is equals to 1 by tan theta. So this is what you can say 3 by 4. This is what my dear 3 by 4 here. So you can write over here theta is equals to cot inverse 0.75. Theta is what my dear? This is cos inverse 0.75, right? So this is I can say Bombay is the correct answer for this questions. Bombay is what correct answer for these questions, my dear. I hope you got it everyone. Now it's a party. Have a look at next questions. Have a look at the next question there. So what's the next question, my dear? Yes, sir. I can say kernel problem. Yes, it's very, very tough. Literally, very, very tough. So listen carefully here. Student, candle, candle problem. Right. So listen carefully here. Those I can say watching thing now. It's very good here. I'm very happy to see that you're enthusiastic. So I'll go through here. I can say candle problem. Yes, it's a good question, student. So keep patience here. Keep patience. It's highly required. Patience here. Patience highly required here. Right for these questions. So what question here? Once I'll read. Once I'll read which I can say two candles. What I can say initially of equal height. Right. H. Okay. Let's go through diagram beta. Go through diagram beta. Can just go through this. You can say there is kind of setup. Right. And in this setup beta, I can there is what I can say candle. There is you can take candle as beta, and I can see both candle also identical in height and also I can say symmetrical distance from what you can say wall. So this is the candle beta. This is the candle, right? So what's a party I can say for this condition here. This is height h. Everything beta mentioned in the question itself, so no need to worry about it at all. Now beta, I can say this height, not height beta, I can say this is separation from here to here A. Further beta, this separation also remains A. From here to here beta, this separation also A. Right. So keep in mind these all things. Yes, beta. So we have to find here. I can say, beta, what we have to find. Beta, with what speed we have to find with what speed the shadow of the left side candle will move along the left wall if left side candle burns down in time t1. That is condition bacha. So we have to basically find its speed. What would we have to find speed here? Okay, this is diagram bacha. Just have a look. Keep patience here for this question. It's a highly a good question here. Yes, beta, highly. It's candle problem. Candle problem literally very good. It's a very good numerical here for your thinking, just improvement of your thinking for advanced level. Anywhere you can watch this video. It's literally very good, bacha. Okay, so what's his question, students? That is, I can say a point which you can keep in mind for solution of these questions. Bacha, you can go through here. I can say for solutions. Yes, beta. According to questions here, they mention this, I can say candle once in time T1. So definitely you can say beta, some height got decreases. Some height got decreases. Right, my dear? Okay. So beta for this condition, you can make here another one more diagram. For beta, I can say which is understanding. Yes. Fine. So you can analyze what's about it. This, I can say candle here falls like this. This I'm just talking about I can select candle beta, right? Another candle there. Make sure कि beta you are understanding here. Okay, this is candle bacha party, right? Bacha, you can take care for this condition because what is initial height is what h. What bacha party h, right? So you can take better for this condition here. What is the height? So you can better just think like that here. Uh, this is what look like a trapezium. Hmm. It's bacha party. This look like as a trapezium, right? Beta. Okay, fine. So here I just go through what's in the questions. Beta, you can say h is a height. What is time? You can say t1. What is time, student? You can say this is what t1. So here for this I'm applying a concept of numeric unitary method. So this is what beta I can say for 1 year. What you can write t1 by h, right? So let us suppose I'm considering this I can say conduct once x. So beta for x, what you can write? This is what x into t1, x into t1 upon h, x into t1 upon h. That is for sure. Okay. The Vachya party for this condition here, what you can say? Let us suppose you can take beta. This height here, I'm considering. You can take x by z. Yes, you can take beta. This height is z, right? So beta, this height here, I'm considering over here. Yes, beta. After wording here. So this height beta, I'm considering from here to here. This is h minus x. And this entire length is what? Z. So what about this length beta? So this length you can write here. This is h minus x minus z. H minus x minus z. Okay, fine. Similarly, beta, you can say this entire length is what? H minus y. So what about this height, which party? You can say this is h minus y. So beta, what about this length? This length, which party? This length, beta, what you can say? H minus y minus z. H minus y minus z. Right, beta? Okay, fine. Then here, what? This is you can write T1. Similarly, bacha, you can apply for T2 also. Similarly, beta, what? You can apply for T2 also. Okay. So, bacha ji, what I can say, this is what the condition here. See carefully because this is beta, the things. Again, this is from here to here. A, beta, from here onwards here. This is remains A. This is remains A. Right. So, bacha party, I can say for this condition. You just don't be confused here. This h minus x, h minus y. Forget. This little bit I just taking consideration because this is our main major part. H minus x minus y beta, and this is what h minus y. Just forget this one. Forget this one. That's it. Okay, fine. So again, I apply beta. What I can say property of similar triangle. Property of similar triangle beta. So this is what beta I can say. This perpendicular upon base beta party. This is what I can say perpendicular y base. Now it's a possible triangle here. So what you can say h minus x minus z beta this one. Upon beta g what you can say a is equals to h minus y minus z upon 2a beta. Simple beta. It's very simple here. I hope all of you get to realize none of you. Lives is enough. Lives beta party. Okay. This a and a beta finished. Right now beta party. Okay. Do cross multiply. This is 2h minus 2x minus 2z is equals to h minus y minus z. Right, Bacha? Okay. Then yeah, there's two further Bacha party. What you can say 2h minus h is h only is equals to what beta? You can say minus y minus z plus 2x plus 2z. Now, what's h? What you can say? So this is that. Fun later. Just take student snapshot. Student take snapshot here. Okay. H beta, what you can write? This is what? Minus y plus z. And this is what? 2x. So h beta finally you can write here. H beta, you can see what? 2x minus x here. So this is 2h. H beta, you will get 2x minus y plus z here. But you know, z is a variable terms. Z is a variable terms here. So beta, just you have to find value of z from here. So z beta, what you can say? H minus 2x plus y. Right now, let us differentiate here entire terms with respect to time. Student differentiate entire term with respect to time. So, bacha ji, this is dz by dt. Beta s remains constant here, so this is 0 minus beta z. What you can say, this is 2 into dx by dt plus d of y by dt. Right now, okay. So, bacha ji, further here, this will go through. So, dz by dt, nothing else, it's a speed of particle. I can say, but it's what you can say speed, which speed we use point. But I can say, but this is what speed. What speed the shadow of the left side candle will move along the left, right? So speed of shadow, yeah. You can say this is nothing but it's a v only. Which is it? I can say this is what I can say minus. Beta, this is minus twice into dx by dt plus here dy by dt. Little manipulation here. Little manipulation was a party. Okay. But just now, yeah, I can say we finished one terms. Beta, this one, x given upon h. So, beta, I can write here these terms. Just rewrite it. I can say first assumption. What we have done, this is student x upon delta t1 is equals to what? You can say h upon t1. Beta, this one here. You can write in the chat, what is this one? This condition here. X t1 upon h. So you can see in the chat, h beta this side here, t beta this side here. So what's the change in time? That is delta t. So you can beta apply this concept over here. Right. Similarly, which I can write for by also here. So what you can see which party this is by upon delta t2 is equals to what beta? H upon t2. What you can say, my dear, h upon t2. This thing which means you can say this is dx by dt, this is by dt. The speed beta in this equation. Let us use. You can fill this data in equation number 1. So v will give us what? Minus dx by dt beta. You can say this is dx by dt. So this is what I can write here. H by twice of h by t1 plus beta g, what you can say? H by t2. Simple beta. So further calculation idea. So just take LCM here. You can say what? This is t1, t2. Then beta, what you can say? This is h. You can take common here. You can say which party. This is basically t1 minus twice t2. What you can say which party? Uh, hmm. So what's answer beta mentioned in the questions here? 2t1 minus t2 here. Okay. So which party I can say? Yeah, x by t1. Yes, beta. Correct, yeah. There is little significant. Yes, beta ji. So what I can say, my dear, further here you can write beta further. This is dz by dt, which is what, my dear? Equals here minus 2 into beta h upon t2. Beta, what you can say? This is h upon t1. Simple beta. Just do further, yeah. You can write speed of the. This is what beta? H, you can say common beta, t1 into t2. Beta, you will get twice of t2 minus t1. But I can see here in the paper hall, and it's a strong recommendation for those candidates this in the paper hall just going to just solve this kind of questions. So I can see there is a bit of trick here which you can keep in your mind. Or you can say not a trick here, it's a formula of Candle problem. What you can say is a formula of Candle problem. So but there is conditions. If your candle has a similar height, identical height, suppression remains same. So beta we can apply this formula directly here. V is equals to S times twice of T2 minus T1 upon beta. This is T1, T2. Yes, so you can keep in your mind these kind of things. It's beta highly required. Yes, beta. It's a very good question. Yes, 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 yes. Yes, yes, it's a very good question explanation. Yes, beta. So just be remember, yeah, for candle problem. For students, I can say for candle problem, it's a strong recommendation, but there is a condition. If both candle has identical height, right? If separation, everything is remains common like this numerical. If everything is common like this, then beta easily you can apply beta this formula. V is what h upon t1 t2 bracket twice of t2 minus t1, twice of t2 minus t1 with party. Okay. Now it's I'm going to study our next numerical. Take beta snapshot. Student takes snapshot here. It's literally a good question, my dear. Yes, because literally it's a very good question. Yes. So this kind of question here, you must practice at home. I can say this for a very good idea in the paper hall. Otherwise, literally, it's not easy to say in the paper hall. You will get easily everything, right? So, my students, there is one more question for plate period, right? Yes, beta. Come. What's question, beta? Here you need to find relative acceleration. But here you have to find what acceleration of two images formed in those two reflections surfaces with respect to each other. So, what's question, my dear? Just take in consideration. Yes, yes, beta. This is I can say there is a pulley. There is pulley. Yes, my dear. This also remains pulley. There is a block. Mass of block is student. You can take this is 2m. Now, student, there is another block. This is what, my dear? 3m. Now, next beta Z, I can say. Yeah, yes, beta, it's literally a bit which I solved previously, kind of a problem. It's a good numerical here. So, yes, beta, this is the setup. This block beta mass remains M. Beta, I can say mirror polish from this side. Yes, beta Z. There is object here. Here, object is here, which is remains at rest. Which is remains at rest. Now, students, I can say yes. This is the condition of the body. So you can take beta. M is what? Mass of, you can say, this block. Again, beta you can take in consideration mirror polish from inner side. Student mirror polished from inner side beta. Okay. So what we have to find? Acceleration, or you can say of image. Relative acceleration you have to find. Find relative acceleration of image. Find beta relative acceleration of image. Yes, bacha. So I will go through this question here. It's a good question, bacha, but uh, good. I mean to say, if you have a good knowledge, uh, if student, I can say you have a good knowledge here. I can say beta say for mechanics. If you have a good knowledge like the mechanics, then you can do this question. Otherwise, it's literally tough. It's literally tough. Okay, come back party for this question here. Jai Shri Ram student. Listen carefully, bacha. So I'll solve this question here individually. First, beta, I'll apply the concept of I can say bacha ji, what you can say. First, beta, I'll apply the concept of NLM. Right. So listen carefully, bacha. So first, I'll beta just do this one, then I'll do this one. So I'll take beta expression this block individual A1. This is what A2. So but in step one here, just make with ABD of this one. So what you can see, this is tension state, this is remains tension state, this is remains tension state. This is let us suppose I'm considering going in downward direction with acceleration A1. So apply it, I can say NLM concept, summation of F net, which is equals to M A beta. So we can write 3mg minus T is equals to 3ma1. Say equation number one beta. Then beta, this you can think beta once. I can say NLM equation from here also beta. NLM beta party for this condition here. So simply can write beta party for the block. Summation of definite tension only here. So T is equals to M into A1. This value beta I can put in equation number one. So you can write my dear, this is 3mg minus ma1 is equals to 3ma1 here. M because beta finish everywhere. So we can write 3g is equals to 4a1. So a1 is equals to 3g by 4. A1 is equals to what, my dear? You can say 3g by 4. It's a true. After this, my dear, in step 2 here, I'll better find this acceleration here. Right. Or do one thing here. I'm going to apply which I can say concept of mirror acceleration here. If you remember in the classroom, in step 2 here, I said velocity of image is what? Twice times velocity of mirror minus what? Velocity of object. Object, my dear, remains at rest. So no need to worry about this. This is remains zero. So you can write velocity of image twice into beta, velocity of mirror here. So what's the beta velocity of mirror? No, beta. This is you can treat it as acceleration of body. So you can write acceleration of image is equals to twice times acceleration of mirror minus you can say acceleration of object. You can transfer the same equation, bacha. Beta, you can convert your velocity and beta same formula here. Just there is v, there is a. That one. This much I can say differentiate. So you can write bacha. A is what? Twice of am. This is twice into beta 3 g by 4 minus 0. Cancel bacha. So acceleration of image. You can write bacha for this block. Let us suppose this is block A, this is block B. So acceleration of image for block A beta, how much? This is 3g by 2. What my dear? Acceleration of image for block A, what you can write? 3g by 2. Right, my dear? Okay. Step 2, bacha. I'm going to apply. I'm trying here only, but maybe I did some, not much clarification. But I'll try. Now, bacha, this is, you can say, beta, what? Step 3 here. Now, beta, I'm going to apply step what I have done. What I applied from step to find, I can say acceleration of image of mirror block A. That is same thing I'll apply for, I can say, beta, to find acceleration of, I can say, image of block B. So again, beta, I'll apply summation of, you can say what? F net, summation of F net, which is equals to MA, which is equals to MA. Right, my dear? So F net here again, system beta. This is, let us suppose, system coming in downward direction with acceleration. You can say A2 beta. So this is which I can say mg force. as a pulling force. Now beta, this is tension C, this is tension C, this is tension C, this is tension C. So you can write what's about it. This is 2 mg beta, 2 mg minus G is equals to, my dear, 2ma2. Now yeah, okay, beta from this diagram here, you can easily write, my dear students, from this diagram, you can easily write this is what beta tension and beta system coming down. So only tension acting on this block. So you can write simply, my dear, uh, this is this T is equals to what beta? This is again here m into a, m into a2, my dear. This T beta I can fit in this equation. Let us suppose equation number 2. So you can write, my dear, this is 2 mg minus ma2 is equals to 2ma2 is equals to, my dear, this is what 2ma2. So you can write simply, student, further just calculate 2 mg is equals to 3ma2, cancel here. So a2 is equals to, right, 2g by 3. A2, what you can say, this is 2g by 3. But it's not a block acceleration, it's this block acceleration. We have to find E acceleration of this, I can say, block B. So beta, for getting this here, again beta, you have to apply beta this concept, right? So you can say, which velocity of image is equals to twice times velocity of mirror minus velocity of, this is limit 0 party. So we can say acceleration of image of block B is equals to twice times what? Acceleration basically with a to a. So we will can write finally acceleration of image of block B 2 to the 4, 4g by 3, 4g by 3. But no, my dear, in this question, what we wish to find? We wish to find basically what is the relative acceleration. Student, we wish to find what is the relative acceleration. Right, my dear? To get relative here, simply better formula apply a1 minus a2 or 2 minus 1, whatever. So finally, I can say last part of the question. What's this? 1, 2, 3, and this is last, my dear. Which is, I can say, straight 4, right? So what I can write to student for this condition? Acceleration of image block A with respect to B. So acceleration of A minus acceleration of B. Minus plus here. So we can write finally what will be 3g by 2. 3g by 2 plus 4g by 3. 4g by 3. Right, beta? Uh, so, bacha, finally, beta, 3 to the 6. 6 beta, 2 3 ja, 3 3 ja 9. Beta, this is what you can say 9g. 4 8 beta, 8g. So acceleration of image beta. So what you can say 17 g by 6. This is meter per second square. No beta. Actually, this is the question beta from ray optics 12th class, my dear. But beta NLM, it's my dear, fundamental concept. NLM, my dear, it's a fundamental concept. So I solve this question, just apply the concept of NLM. But basically, beta, this question from 12th class, ray optics, my dear. Yes, in which class you are, beta? Okay, fine. So I can say that it's a good question, beta. Take snapshot, beta. So you can take snapshot for this question. Yes. So this is the beta, I can say, session for 12th class. Now, soon I'm going to stop the session here, right? I'll see beta.